Here, we are going to use Minitab to look at a first-order multiple regression model. We have a data set that compares the level of CO given various brands of cigarettes. For this multiple regression model, we have several predictor variables and one response variable. Our predictor variables are the level of nicotine, tar, and the weight. Our response variable is the level of CO. To generate this model, click on Stat, Regression, Regression. Now we enter our variables. Our response, or dependent variable, is CO. Click Select. And our predictors are tar, click Select for each, nicotine, and weight. If we click OK, Minitab will generate an output that also provides a regression equation. The regression equation is 3.20 plus 0.963 times tar minus 2.63 times nicotine minus 0.13 times weight. To interpret this equation, notice that the line passes through 3.20, and to interpret the model, we must look at the unit change in each predictor and assume that the other predictors remain constant. To clarify, the amount of CO increases by 0.963 unit for each unit increase in tar, assuming that the level of nicotine and the level of weight remain constant. Similarly, the level of CO decreases by 2.63 units for each unit increase in nicotine, assuming that the weight and the amount of tar remain constant. And finally, the level of CO decreases by 0.13 unit for each unit increase in weight, assuming the other two predictive variables remain constant. From this output, we can also look at R squared value and the mean square error, 2.09, which is the estimate of the variance. Now, we want to test the significance of this model using an F-test. The null hypothesis for this F-test is when all coefficients are 0. The alternate hypothesis is where at least one of the coefficients is non-zero. In Minitab, this exists in this analysis of variance section. As we can see, the F value is 78.98 and our p-value is close to 0. Since the p-value is close to 0, we reject the null hypothesis. This means that at least one of the coefficients is non-zero. Please notice that we cannot determine which variables contain coefficients that are non-zero, but this test tells us that at least one is non-zero. To determine the significance of the individual predictors, we use individual t-tests. Here, as we can see, the p-value for tar is close to 0. This means that tar is the most significant of the predictor variables. Similarly, weight, the p-value is 0.974, which is not close to 0. Therefore, weight is the least significant of the predictor variables.